When people first encounter modern language models, one of the most surprising discoveries is that the quality of the answer often depends less on complicated instructions and more on how the task is framed. Many beginners assume that interacting with a language model requires elaborate prompts, complex logic, or carefully engineered commands. In reality, some of the most powerful prompting techniques are also the simplest. Understanding when simplicity works, when examples help, and when role framing changes the behavior of the model is fundamental to effective prompt engineering. These ideas are commonly described through three related techniques: zero-shot prompting, few-shot prompting, and role prompting. To understand why these techniques work, we must start with a mental model of how language models actually respond to prompts. A large language model does not read instructions the way a human expert would. It does not interpret the prompt as a set of rules that must be logically followed. Instead, it processes the prompt as a sequence of tokens and predicts what sequence of tokens is statistically likely to come next, based on patterns learned during training. This means that the prompt acts as a contextual signal that activates certain behavioral patterns inside the model. When a prompt resembles patterns the model has frequently encountered in its training data, the model can produce high-quality responses even when the instructions are extremely simple. This is the core principle behind zero-shot prompting. Zero-shot prompting means asking the model to perform a task without providing any examples of how the task should be completed. The prompt simply describes the task, and the model attempts to produce the appropriate output based on its prior training. At first glance, this might seem almost magical. How can a model perform tasks it has never been explicitly shown in the prompt? The answer lies in the scale and diversity of the data used to train large language models. During training, these models are exposed to enormous amounts of text from books, articles, websites, code repositories, documentation, conversations, and educational materials. Within that vast dataset are countless examples of questions followed by answers, instructions followed by explanations, problems followed by solutions, and descriptions followed by summaries. As a result, the model has internalized statistical patterns that connect many types of tasks with appropriate responses. When we ask a model to summarize an article, translate a sentence, classify sentiment, or explain a concept, we are often triggering patterns that were already strongly represented in the training data. Because those patterns are familiar, the model can perform the task even when no examples are provided. This is what makes zero-shot prompting both powerful and elegant. However, zero-shot prompting does not work equally well for all tasks. Its effectiveness depends heavily on whether the task resembles patterns the model has frequently encountered before. Tasks that are common in written communication tend to work extremely well in zero-shot mode. These include summarization, explanation, translation, rewriting, brainstorming, and answering general knowledge questions. When the prompt clearly describes the task and the task itself is common, the model can produce surprisingly strong results with minimal instruction. One of the most important principles in zero-shot prompting is clarity. Because no examples are provided, the prompt itself must establish the full context of the task. Ambiguity increases the number of possible interpretations, and the model may choose an interpretation that differs from the user's intention. Clear language reduces this uncertainty. Another key principle is alignment with natural language patterns. Prompts that resemble how humans naturally ask questions or give instructions tend to perform better. This is because the training data contains many examples of natural language instructions followed by responses. When a prompt mirrors these patterns, it activates familiar statistical structures within the model. A common mistake among technically trained users is the tendency to overcomplicate prompts in zero-shot scenarios. Engineers sometimes assume that the model requires extremely detailed technical instructions. In many cases, this actually harms performance. Overly complex prompts can introduce conflicting signals, dilute important instructions, or push the model toward unusual patterns it has seen less frequently during training. A short, clear instruction often performs better than a long paragraph filled with constraints. For example, asking the model to summarize this article in 3 sentences is often sufficient. Adding multiple layers of explanation about what a summary is, how summaries should work, and why summaries are useful does not necessarily improve the result. The strength of zero-shot prompting lies in its simplicity and speed. It allows users to quickly test whether the model already possesses the capability needed for a task. If the model performs well, no further prompt engineering may be necessary. However, when tasks become more specialized, ambiguous, or unconventional, zero-shot prompting may begin to struggle. In those situations, another technique becomes extremely valuable. This technique is known as few-shot prompting. Few-shot prompting works by providing the model with a small number of examples that demonstrate the desired input-output relationship. Instead of merely describing the task, the prompt shows the model how the task should be performed. The model then continues the pattern by generating an answer for a new input. This approach is effective because language models are extremely good at pattern completion. When the prompt contains several examples structured in a consistent way, the model learns the transformation pattern within the prompt itself. In essence, the prompt temporarily becomes a miniature training dataset. To illustrate the idea, imagine we want the model to classify sentences according to sentiment. A zero-shot prompt might say classify the sentiment of the following sentence as positive or negative. The model may perform reasonably well, but its interpretation of the task might vary. If instead we provide several examples, such as a sentence labeled positive and another labeled negative, the pattern becomes explicit. The model sees the relationship between the input sentence and the output label, and is more likely to reproduce the same structure for new sentences.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.